All right, so now we're starting the calculator permitted portion of the review, and we're going to be looking at example 8, showing that we can find the solutions of the equation that are in the interval from 0 to 2 pi. That's important to note. And the first one we're going to look at is B. So the first thing I usually try is I try to make it look like a traditional, and I don't know why that just happened, a traditional quadratic equation or something where I can try to factor. So I'm going to start by adding that 1 to the other side. So this would be 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Now some people like to think of this as 2x squared plus 3x plus 1, and they factor it that way. But we should be able to factor these with the cosines as well. But if you need to write it with the x, that's okay. I could do factor by grouping here, so that would be 2 times 1, which is 3. So it has to be 2 cosine squared theta plus 2 cosine theta plus cosine theta plus 1. Factor out a 2 cosine theta, and that would leave me with cosine theta plus 1. These two have nothing in common, so we have to pull out a plus 1, and we're still left with a cosine theta plus 1. So it looks like we have a cosine theta plus 1 and a 2 cosine theta plus 1. So again, if you need to do that with x squared and x instead of cosine theta, that's fine. We set each of these equal to 0, so we can solve it. So this would be plus 1 equals 0, so we would subtract 1. So one solution that I'm going to pursue is when does cosine of theta equal -1. The other one is 2 cosine theta plus 1 equals 0, so I'm going to subtract 1 and then divide by 2. So I'm looking for when cosine of theta is -1/2. Now cosine of theta being -1 is where on the unit circle can we have an x that is -1. And that only happens in one place. That happens when theta equals pi. And that's if we're staying within one revolution of the circle, which we are. And then here, cosine being negative, well, all science teachers are crazy means that we have to be in either quad 2 or quad 4 because sine and tangent are positive there, but not cosine. And for the cosine to be 1/2, that means the x value is 1/2. That means the y value is square root of 3 over 2. So this is a 60-degree angle. So that would mean we're looking at pi over 3. So this is 2 pi over 3 and 4 pi over 3. So we have 3 solutions that fit the equation pi, 2 pi over 3, and 4 pi over 3. For C, I would first start off by subtracting the tangent over to try to get a 0 over there. And then notice that they both have a tan in common, so I would pull out a tan theta. I would still have 3 tan squared theta minus 1. Set each of them equal to 0. So this one will be tan squared theta equals 1/3 because you'd add 1 and divide by 3, and then we would have to take a square root of that. So it's going to be tan theta equals plus or minus. I'm going to leave it as 1 over the square root of 3 because the square root of 1 is just 1, because that'll help me with more with which is the opposite and which is the adjacent. So this is really like 1/2 over square root of 3 over 2. Okay, so for the tan theta equals 0, let me mark off that this is the end of that previous problem. Tangent can only equal 0 if y is 0. So that would be at the points 1, 0 and at -1, 0. Because that would be y over x, so 0 over this and 0 over this. So those are the angles of 0 and pi. Okay, and then for tangent to be equal to theta of -1/2 over square root of 3 over 2. First of all, that means that we are in a quadrant where tangent could be negative, so that is in quads 2 and 4. And the y value is -1/2, or it's just 1/2 because it'd be negative square root of 3 over 2 for the x value right here. But the main point is that if your half is your height of your triangle, that means you're a 30-degree angle. So this would be pi over 6. So that's going to be a 5 pi over 6. And down here, that's an 11 pi over 6. And then because we also have tangent theta of positive 1/2 over square root of 3 over 2. We're also going to get pi over 6 and 7 pi over 6 because those would be the other 2 pi over 6's in quads 1 and 4. Okay, so that's that for that one. E is sort of an interesting one because you have tangents and you have secant squareds. You have to remember anytime I see a squared something, I might want to consider whether or not my Pythagorean identities are involved. So I need to look at what that would be. So remember, if you have sine squared theta plus cosine squared theta equals 1, secant squared would happen if we divided everything by cosine. So, because 1 divided by cosine is secant. So just imagine doing that all the way across. Sine over cosine is tangent squared, cosine over itself is 1, and secant squared. So we can replace secant squared with tangent squared plus 1. So this would be 2 tan theta equals tangent squared theta plus 1. Since the tan squared is positive, I'm actually going to move the 2 tan over. So this would be 0 equals tan squared theta minus 2 tan theta plus 1. And then that is a quadratic, x squared minus 2x plus 1 if you think of it that way. I don't need factor by grouping since there's not a number in front of the tan squared. So this is going to be a tan theta and another tan theta if it factors. And factors of 1 are 1 and 1, and they both have to make it add up to a -2, so it's going to have to be 2 negatives. So this is really only going to be one solution set to solve. So because if you add it over both times, you're going to get tan theta equals 1. Now there are 2 places where tangent could be a positive 1. First of all, tangent's positive in quads 1 and 3. And for tangent to be 1, the side of the triangle, both sides had to be exactly the same. So that's a 45-degree angle, an isosceles triangle. So this happened at pi over 4 and at 5 pi over 4. So that would be the answer for that one. Okay, for this next one, we see a lot of things going on. We have tans and cosecants and stuff on both sides. I'm going to try to start off by just moving everything to the same side. So this will be tan theta cosecant theta plus cosecant theta. It's so hard to write. Minus 2 tan theta minus 2 equals 0. It doesn't look like much, but it is 4 separate terms, so we can try factor by grouping. So this would be cosecant theta. That would leave me with a tan theta plus 1. This has a -2 in common, so pull that out, and we also are left with a tan theta, and -2 divided by itself is positive 1. So this works out into tan theta plus 1 equals 0, times cosecant theta minus 2 equals 0. Now we can set each one of them equal to 0. So tan theta plus 1 equals 0, and cosecant theta minus 2 equals 0. This would be tan theta equals -1. This is cosecant theta equals 2. We would change that to sine and flip the fraction. So that's going to be sine equals 1/2. So tangent, remember, can only equal 1 if you're at a 45-degree angle, and tangent is negative in quads 2 and 4. So that makes this 3 pi over 4 for this one, and it's going to be 7 pi over 4 for down here. So 7. And then sine is positive 1/2. First of all, sine is only positive in quads 1 and 2. And if your sine is 1/2, that means you're on the unit circle, you have a y value of 1/2. So that means this is a 30-degree angle. So that's going to be pi over 6, and this over here would be 5 pi over 6. So our 4 angles are 3 pi over 4, 7 pi over 4, pi over 6, and 5 pi over 6. Okay, for number 9, we're trying to express this trigonometric function expression as one angle in an interval between 0 to 2 pi. We're not evaluating anything. So this is trying to recognize if you know your formulas or not. So notice that sine and cosines are mixing together here, which means we're being social. and that means it's going to be the sine formula, and if you're sine, you're social and agreeable, so it's going to be an addition problem. So this is going to be, my ink's not wanting to work, hang on just a second. There we go. This will be sine of the two angles added together. Uh-oh. Okay, my word was just being really funny there for a second. But we decided that this was sine of an addition of two angles. So sine of pi over 2 plus 5 pi over 3, and we want to write that as a single angle between 0 to 2 pi. So we need to get a common denominator. So I'm going to multiply the first one by 3 over 3, and the second one by 2 over 2 to get a common denominator of 6. So this is 3 pi plus 10 pi all over 6. That's 13 pi over 6. That's too much because that's over 2 pi. So remember, if you subtract off 2 pi, which is 12 pi over 6, that gives me just pi over 6. So this is sine of pi over 6. Okay, let's look at D. Cosines are both together, sines are both together, so that's antisocial behavior. So this is the cosine formula, and cosine is disagreeable, so instead of plus, this will be minus. So 2 pi over 3 minus 5 pi over 4. And we're going to be looking at, again, having to get a common denominator, so this would be 2 pi over 3 times 4 over 4 minus 5 pi over 3 times, or excuse me, 4 times 3 over 3. So that's going to be 8 pi over 12 minus 15 pi over 12. That's negative 7 pi over 12, which is 2, not in 0 to 2 pi. So 2 pi, and where the denominator of 12 is 24 pi over 12. So 24 minus 7, and it is really late, so I'm going to do that the long way. Very tired. So that's 17. So this should be cosine of 17 pi over 12. Okay, and for this one, it's tangent, obviously, because it's got the tangent formula, and that's the only one we have that has tan in it. So remember, the addition formula has the plus on top, the subtraction formula has the subtraction on top. So this is the addition formula. So tan of pi over 3 plus 5 pi over 6. We need a common denominator. We only have to change the first fraction. So that's going to be 7 pi over 6. And I need a short break, so I'm going to end this part, and we'll pick up with number 10 in the next portion.